My name is Ernie Humphrey. I'm the Vice President of Educational Programs at Proformative, the online community for corporate finance, accounting, treasury, and related professionals. First, I'd like to welcome everyone to our webinar entitled The 3 Stages of Cloud Economics. How do I maximize savings and increase profits for my organization? Investments in information technology have a direct and fundamental impact on the success of an organization's revenue-generating activities. As a consequence, the business's financial leadership has a critical stake in understanding and influencing IT decisions. The content this morning will focus on how finance executives are in a unique position to lead efforts in building profit models around well-planned cloud implementations and make the IT organizations of their companies aware of their impact on revenue and profitability. I would like to thank SunGuard Availability Services, Cisco Systems, and EMC, whose commitments to thought leadership help make this event possible this morning. A quick note on today's agenda. First, we will hear a presentation from our featured speaker, James Statton, Vice President and Principal Analyst, Forrester Research. And then we will move to a panel discussion where we will spend the remainder of our time. We have devoted 30 minutes to the Q&A so our audience can leverage the tremendous opportunity to ask questions to James and our other renowned panelists who I will introduce to you prior to the Q&A session. Again, we would like this webinar to be an interactive experience for you. So if you have any questions at any time, please go to the questions area in your GoToWebinar control panel and send us your questions. We can't promise to get to them all, but we will do our best and follow up on any questions that we did not get to during the webinar this morning. A few logistical notes. We will be sending out soft copies of the presentation to all attendees this morning, and the event is offering CPE credits for the CPAs in today's audience. There will be an email sent out after the webinar is over this morning with the contact information for Tanya Walsh, who manages the CPE credit administration for Proformative. So if you'd like CPE credits, please send her an email if you did not select the CPE credit box when you registered for the event. Just a quick word about Proformative. Proformative is the online resource and community for finance, accounting, and treasury professionals. We offer a noise-free platform which allows our constituency to ask questions, get answers, and share their knowledge. Okay, let's get started by introducing our featured speaker, James Statton, Vice President and Principal Analyst, Forrester Research. James serves infrastructure and operations professionals providing insights and best practice use of emerging infrastructure technology and services trends, including cloud computing, IaaS, and public and private clouds, strategic right sourcing, infrastructure consolidation, and application-specific infrastructure optimization. He is the author of Best Practice Analysis on Maturing Your Virtualization Practices, Building a Cloud Computing Consumption Strategy, and Optimizing Web Infrastructure for Blazing Fast Performance. He also advises clients on IT's role in business empowerment and hero enablement. James has more than 20 years' experience in the industry, having served as a reseller, vendor strategist, CMO, journalist, and analyst for companies including Autodesk, Azul Systems, Gartner, Rockwell International, and Sun Microsystems. With that, I'd like to hand it over to James Statton. James?
Thanks so much, and thanks everyone for joining us here today. I am James Statton, and I'm going to take you through a look at cloud computing from a financial lens. It's actually a really important way to look at cloud computing because once you understand what cloud computing really is, there is a unique economic model that is behind these types of services, and it's one that can actually provide your company with new options and new capabilities. One of the basic things to understand about cloud computing is that one of the things most of your company will understand about cloud computing is that cloud computing provides the ability for you to sort of scale up services. So if a service gets busy, like your company has a Christmas or a new marketing app campaign is doing extremely well, cloud lets you scale up those services very, very well. And that's good from an economics perspective, but the real benefit and the real financial gain that you get from cloud computing is when you actually can make it scale down. And that's going to be a lot of what we're going to talk about here today, because understanding how to make services scale down is actually part of how you advance through the 3 stages of cloud economics. Now let's do a quick level set. One of the important things to understand about cloud computing is exactly what is it and what makes it different. what makes a cloud is the definition that you see on the slide with the blue background that was just there. There are three key elements to cloud computing. The first element is that cloud computing services are highly standardized services. And what do we mean by that? We mean that every customer who uses that service gets exactly the same service. And because they're getting exactly the same service, you know that behind the scenes, they're using standardized, automated capabilities to deliver those services with economies of scale. And the economies of scale is where the beginning of the economic model starts. The second part of any cloud service is how you pay for it. And most cloud services have a pay-per-use offering. Oftentimes this will count the number of users that access the service, which is typical of software as a service offerings like Salesforce.com and NetSuite. And then there are services similar to Amazon's web services, GoGrid, and other types of clouds that are out there, including SunGuard services, that are pay-per-use in the amount of resources that you consume. So you light up a virtual machine, you start paying for it. You store something in the storage environment, and you start paying for that storage. The last part of any cloud service is that these services are meant to be autonomously consumed. You don't call a sales guy to set them up. You don't call a help desk to configure the service. You don't wait 24 hours for a service to be enabled. You're able to go into a portal or an application programming interface and request the service and have it deploy automatically in about 15 minutes. This speed we'll come back to later in the presentation because that's the biggest driver for why people consume cloud services to begin with. Now, the next thing to pay attention to is that there's a significant amount of hype out there in the market. And as a result of that hype in the market, you hear lots of people talking about solutions and calling it cloud, and they don't meet this definition. That's really what you want to use this definition for, is to be able to determine what really is a cloud service. And the second thing that people will say is that, well, in 5 years, everything's going to move into the cloud. We fundamentally disagree with that because there's a lot of applications that just don't fit in cloud environments. They're not standardized or can't take advantage of standardized services like this, and they can't activate the economics of a cloud platform. In fact, when you look at the full portfolio of cloud services that are out there in the market, you'll see that there's traditional IT, dedicated hosting, virtual machine hosting, and other services like that, which have traditional economics. And they fit with applications that don't have this elasticity or the ability to activate the economics. So you get the economics mostly in the 4 blue services that you see listed here on this slide. So that's where we're going to actually concentrate most of our conversation today, is around how customers are using these services and how those economics can be applied to your organizations. Now, I mentioned that speed is the #1 reason that companies are using cloud services. It's because they can see that within 15 minutes I can set up and provision these services, and I can actually start using them within that same day. If these are services going to be facing new customers, it's the ability for you to deliver a new service or provide marketing materials to customers in a very, very rapid sense. And this breaks the model we've seen with most traditional IT, whether it's outsourced or it's done by your own IT department. It's pretty rare that we find any of those class of services that can deliver a complete service to you in 15 minutes or less. Now, beyond the speed, we also get a lot of interest from companies around the belief that this reduces the total cost. And when used correctly, that's absolutely accurate. We also find that there's a significant interest in greater manageability and flexibility. And how this comes from a cloud service when a service is highly standardized is flexibility means the ability for the developer to work independently or the business units work independently and not have to deal with their corporate internal processes. What that should suggest to you, which is correct about what we see in our survey data about consumption of cloud, is that a lot of cloud consumption bypasses the central IT department. Now, the next thing that's worth understanding is how the cloud is actually being used. And the best way to demonstrate that is to actually talk about some companies and how they are using the cloud. The first one I want to call attention to is the Associated Press. As many of you know, this is a syndicated news agency that provides news coverage in multimedia formats to traditional newspapers and traditional websites. Their business model is centered around these large traditional media outlets having subscriptions to their services. And that doesn't really work for some of the new news outlets that are out there that are built using mashups, mobile applications, Twitter, and other social media, and they need a different business model. And the Associated Press didn't have a means of communicating and working with these organizations. So they went around their formal processes and created a new service in the cloud that exposes an application programming interface to these types of companies that allows them to get immediate access to content. And they don't have to pay for it right away, but AP logs how they use the content and can bill them in arrears. And this allows new business models and new relationships to be created and allows the Associated Press to understand and observe the patterns of use these new companies have so they can put the right business model behind this pattern. And this entire offering is hosted in 2 public clouds. There's nothing inside of the AP data center that's touched to deliver this capability. And it was developed entirely by their developers and delivered out into market in less than 6 months. The next example comes from the financial services market, which you would normally assume is someone who is very concerned about using public cloud services due to security risks and regulatory environments. In this circumstance, NASDAQ, who had actually been using the cloud for the past 3 or so years, built a service that is specifically designed to keep hackers and keep traffic they don't want out of the NASDAQ data center. What they do is they have a service that takes all of the traffic from the prior day of the market, and they copy that up to a public cloud outside of their firewalls so that their clients who want to do algorithmic trade simulations, do risk analysis simulations, and do other types of things that would simulate trade but need a full market to test fully, they allow them to subscribe to this data set and exercise it from a public cloud. It's actually created a brand new service for the NASDAQ, which allows them to satisfy this need without exposing security concerns to any of their standard clients or the actual market during the day. On the next example comes from the U.S. Army, someone else you would think would be worried about security, and they're doing something very common in the cloud, which is test and development. In particular, they're doing scalability testing of a military application. And why they're doing this in the public cloud, there's actually 2 reasons they're doing it. Number one is in order to test the scalability of this application, they don't need actual current troop positions. All they really need is historical data about where troops have been in the past and previous battle histories. They take this information, put it up into the public cloud, and do scalability testing here so they can figure out how big this application will actually get. The value of that is by putting some transparency into capacity planning for their next data center. So by testing the application here, they can determine is it going to need a data center that's going to ultimately cost $25 million or $50 million. And that's actually the magnitude of savings they expect to achieve by this more accurate capacity planning process. So they're not going to actually run this application when it's finished on a public cloud. They're going to bring it back into their own data center. And this is a pattern that we see from a lot of companies who test things on the cloud and then bring them back into their own data center for final deployment. Another example is one that you would expect to find a lot in the cloud, which is startup companies who are creating new capabilities that just would not be feasible or possible without the cloud. And this is a company that's definitely taking advantage of cloud economics. It's a company called Pathwork Diagnostics, and what they do is oncology tissue sample analysis. And in order for them to do this analysis, they have to have a massive data warehouse that has millions of other samples of oncology tissue and their full DNA profile. Because what they do is they take new tissue samples that come from doctors that are undiagnosed, where they're not sure what type of cancer it is, and they will do a DNA profile of that and then compare it to all the rest of the DNA samples they have in their database, allowing them to come out with a high predictability of what this cancer is most like from a total DNA profile. And this is a revolution in the industry because prior to them doing this analysis, it would take weeks to determine what type of cancer someone might have. Now that can be turned around in as little as 24 hours. Now, how do they use the cloud? They use the cloud to build the data warehouse. It doesn't run in the cloud. It's only built there. So they go up into the cloud and activate thousands of virtual machines, consume terabytes of data to do this. And as soon as the new version of the database is finished, they leave the cloud. As a result, their consumption of the cloud is bursty. And whenever they're not using the cloud, the bill for the cloud costs them zero. And that is how you turn on cloud economics. You constantly want to be paying attention to the bill and the billing model that exists in the cloud. And so there's a few basics about cloud economics that are really important to understand. First and foremost is that because it has elastic scale, it allows you to add capacity just in time. Now, in some prior traditional infrastructure models, just in time might have meant the next day or within a week. As I mentioned before, clouds can deliver new capacity in 15 minutes or less. And that is what we mean by just in time. So being able to have an application that has a pretty small footprint most of the time, but as soon as it gets busy, it gets more capacity, is a core element of cloud economics. And usually this is governed by a technology called load balancing. The second key thing to understand is that because it's pay per use, you keep your costs low. When you add another server, when you add some more storage, when you add some more network bandwidth, you pay for just the amount that you turned on. And you pay for it on an hourly basis, which means you don't have to commit to it up front. In fact, in most clouds, you don't have to have any upfront commitment financially of any kind. And if you don't continue to use the service, you're not obligated and there's no ongoing bill. The third thing that's important to understand about cloud economics is how self-service really drives productivity, where the first two lines talk very much about the cost that you will incur from using the cloud. The third is about costs you avoid inside of your own organization. When developers can, by themselves, activate these services, and where applications can activate these services on their own based upon true traffic patterns that they are being impacted by, it means that you're reducing the internal operational costs, the internal people costs within your own IT department. And that's extremely valuable. And it's usually a part that's left out of a lot of people's business cases when they're making the ROI analysis around cloud. So make sure that you don't make that mistake and that you count the lower people costs that are associated with delivering this. Now, once you can sort of get the basics of cloud economics down, you can start applying it to your business and applying it to any particular business circumstance. One company that is heavily taking advantage of the cloud is this company here, Voicepay. This is a company that is trying to take business-to-business transactions between small businesses and between small businesses doing business with large businesses and move this payment system away from checks. In fact, most of the small business market, unfortunately, continues to talk to each other and exchange money between each other using checks, to the point of 90% in the United States who still do this. As you can imagine, this is an extremely slow payment process, and as a result, it is one in which you don't really know for sure whether that check's going to clear until maybe a few days later. And so this is very problematic for the small business market, particularly in the recessionary environment that we're in right now. So what this company does through their service called AP Assist is it allows them to electronically pay each other through a broker system that is set up here. And what Voicepay does is they set the system up, they validate each of the companies that participate in this, and then they use payment clearinghouse systems like First Data and ADP in order to ensure that the payments actually goes through and that credit is properly applied in all directions. Now, in order for them to do this kind of service, they knew that when they first got off the ground, there would only be a few transactions. They'd only have a few small businesses signed up. But they knew that once this started to take off, even if they didn't add a huge number of additional companies, the volume of transactions per company would start to climb. And that's exactly what has been happening since they launched the service. So since they were going to have significant amount of burstiness, they did not want to put this on a traditional hosting platform where they had to forecast the total capacity and then would pay for the total capacity as it goes, because they want to keep the economics of their solution extremely thin as well. And so what they do is they put their service onto a public cloud that only activates services as soon as they are needed. And that allows them to match their spend to the amount of profit that comes from this capability. And that is really the key to turning on cloud economics, is to make sure that you can tie your cost to whatever revenue is coming directly into the door. And cloud computing lets you get very, very precise about doing that. Now, the other thing that's important to understand about cloud computing, and particularly pay-per-use, is that it is an unusual pricing model, and one in which you can draw some incorrect conclusions about it. But there's some analogies to other payment systems we're quite familiar with, which are very applicable here. And that's why you see the Starbucks logo here at this point, because Starbucks is actually the master at something that we've had in the market for a while, which we call cost optics. And what we mean by this is, in traditional IT services, of whatever form they come in, you tend to pay for them on an annual basis, and you tend to pay for them up front, or spread out over 12 months on a monthly bill, but you know what the total annual cost is going to look like. In the case of Starbucks, particularly if you use the Starbucks card, the cost optics are around the individual drink that you purchased that day. And as a result, Starbucks seems to be very easy to become a habit that you would do on a regular basis, even on every single day. Because when you see the optics of the individual drink, you don't see the optics of what Starbucks cost you on an annual basis. And in fact, if Starbucks were to come to you in January of the next year and say, thank you for your loyalty, thank you for your business last year, would you like to prepay for all of your coffee? That'll be $1,575. You would probably spill your coffee. And that's specifically why they don't do this, because they want you to continue to take it by the drink, so you'll always believe that it is low cost. And that's exactly what public clouds are doing when they expose their so many cents per virtual machine models. It looks cheap. The way that you find out whether a cloud is really cheap or not is where you take the published pricing that they have, which is usually based on an hourly rate, and then you take a look at what that would mean if that hourly system, that system that you fired up, wasn't on for an hour, but was on all day long for an entire month. And that allows you to take this price here, times 24 hours, times 30 days, and get a price. And this price is a little bit more challenging to swallow, especially when you compare it to the costs of traditional hosting. So $57 is just for the virtual machine. Then you add in the per hour networking cost and the per hour storage cost, and you get a pretty nasty price, especially when you compare that to traditional hosting, which can be as little as this. So as a result, you could be consuming the cloud in a traditional fashion where you light things up and you leave them there, and you will pay between 3x and in some cases 5x more than what traditional hosting would have cost you. As a result, you have to actually treat clouds very much the way that you would treat other services that have this kind of per hour or other meter to how they're costed out. And the best example of that is rental cars. You know, we don't go on a business trip to Chicago and then buy a car in Chicago. Even though if you took the cost of the car and then you divided it all the way down to what it should be per hour, it would be cheaper per hour to own the car. But we don't do that because we don't want to be paying for the car when we're not in Chicago anymore, which is specifically why rental cars are very expensive per day compared to the cost of owning a car in that city, because you always want to be bringing the bill back to zero. And the way you bring the bill back to zero in almost any application is where an application has either elasticity, meaning that it scales up where you add additional resources as it gets busier, or has transiency, which means that you only launch that application periodically. Say at the end of a quarter if you have particular applications that need to come on to close the books. That's a typical example here. Now the key thing from this point is to say, okay, if I understand the basics of cloud economics and I understand the context in which the economics are applied to other parts of my life and my business, then what is the key to actually getting the cost savings to come out of this? Well, the first key is to take a look at elastic scale and actually flip it over, because scaling up is a great way to incur more bill. As a result, scaling back is a way to save money. And that's what you really want to be focusing on, is how, when my elastic scale model, can I constantly be coming down, bringing the application down into its smaller footprint, and then getting that small footprint, that base footprint, as small as possible. The next thing you want to pay attention to is what scales, because of what we see with a lot of traditional applications that exist in data centers today, if you were to pick them up and drop them into a cloud, they would require a significant base footprint, and they may not scale all that elastically. What this means is that you have to actually look inside these applications and say, do I really need that big of a base footprint? Are there elements of this application that really should not go into the cloud, but other elements are really well suited to that? And can architecturally I deploy more of a hybrid implementation? That's the second thing that's really important. Then the third thing is where you place things and when you place them actually has an impact. In some particular cloud services, for example, they have what's called off-peak pricing, which means that if you load this application at late night, you can pay less to have it hosted there. Batch applications are a great example here. Any transient application that isn't time-based would be great to use this for. In other cases, there are certain cloud services that you can tap into that have different discount rates based on how you use them and have different pricing models based on what they bring to the solution. So an example that's pretty well known in the industry here is a content delivery network like an Akamai. This is something that caches the front end of web pages, things that are usually the first things that you request when you go to anybody's website. By taking advantage of a CDN instead of putting something in the cloud, you can actually incur a different cost model, which may be dramatically cheaper. So you have to kind of understand what's it going to take for my organization to change these economics. So let's switch back now to Voicepay so we can talk about how they activate cloud economics. Because as I mentioned, their model is highly elastic, so it automatically turns that on. But where they make profit is that they get a really small set of change for every transaction that goes through. So they charge 40 cents per transaction that goes through, and their profits have to go underneath that, which means when they deliver any transaction, it has to be delivered at significantly less than 40 cents in order for them to make a profit. So they have to constantly be looking at how I lower the cost over and over and over. So as I mentioned, one thing that you can do here is that you can make sure that you only scale the elements that are necessary to scale and that everything has a really tiny footprint. That is the core to how they've designed their application and how it is laid out in the environment. The next thing is they realize that if there's transaction flow that goes up and down the network or causes servers to have to be activated or stores additional storage inside their environment that is not related directly to a transaction, they pay for that. So they try to minimize that as much as they possibly can. So where I mentioned a content delivery network is one element you can use to supplement cloud to keep the overall cloud bill down, they take advantage of other caching architectures as well. And whenever they have the opportunity to batch up some work where during off hours or in a very small opportunity, they take advantage of that as well. So they watch very closely what the economics are, what the model is in the cloud, and they take advantage of that. They also take advantage of cloud native capabilities that they can use to support their application, but do not incur virtual machine costs. In this circumstance, they use a natively hosted service bus, natively supported access control, so that elements that are charged on a per-hour basis that provide those base capabilities. So this kind of thinking, by working with, say, the enterprise architecture team, the development team, and your organization, allows you to start to move through the stages of cloud economics. Now let's talk really quickly about what we mean by the stages of cloud economics. The first stage is the one in which you are learning about the cloud, you're understanding what cloud economics are, and you're really trying to just build new applications, or in some cases transition some applications from your data center to the cloud. And in most cases, when you're in stage one, the focus is on, can these applications elastically scale? And what's it going to take to do that in a consistent fashion, a performant fashion, and one where we have high availability and where we can recover the applications. Now, these basic learnings are critical in the first stage to really understand how the cloud works. The downside in stage one is once you've figured out how to get the elastic scale, you have to make sure that when it spikes, which it inevitably will spike, it's spiking for the right reasons, and it is spiking in a cost curve that actually matches the revenue that comes back to you or the business value that comes back to you from that service scaling up. Now, as I mentioned, some application components don't scale well and actually should not ever move into the cloud, which is why you actually want to focus on a hybrid deployment, where elements of your solution that can't take advantage or activate cloud economics are not presented there, and only the elements that can are. So a good example of that is a customer who took their website and realized their website was actually composed of 3 tiers. The first tier was their database tier, which was based on Oracle RAC. It had a set footprint that did not elastically scale, and that footprint couldn't ever go away. So they couldn't scale it, and there was no transiency aspect to it at all. So they kept that on traditional hosting in a dedicated environment. In this circumstance, this customer did not virtualize this workload. They just kept it where it was. In the middle of their application was the application logic tier. And this logic tier mostly didn't scale very much either, but it could be virtualized, and so they were able to put it into virtual hosting, which reduced hardware costs associated with the application, but it was still a static deployment, which meant that they were better off putting this into a 12-month contract. Then they took a few other app logic elements that did scale, and their entire web tier, which scaled up and down like crazy and could easily be governed by load balancing, and moved all of that into the cloud. Now, by doing this hybrid implementation that they did here, they actually were able to achieve a 90% cost reduction in the platform hosting costs for this entire service. So we're not talking 10 or 20% savings. This is a dramatic savings that comes from simply activating the economics that are most appropriate for the parts of the application where that can be applied. And this is a real use case, and it's published on the Forrester website, but I'm not able to use the brand name here today. Now, if we take that basic model and we apply it to our overall organization, we will actually find that those 3 balls that I showed in the prior slide, you actually have 2 sets of those, or over time you should have 2 sets of those. You have your physical data center environment where you would lay down physical applications. You have a virtual static environment where you were already virtualizing workloads inside of your company, and you're probably going to want to build sometime over the next 2 years an internal cloud that allows you to activate some cloud economics, but within a fixed environment and within your security perimeter. You should also already have, and you certainly will have over time, a traditional outsourcing environment for hosting applications and for them to be managed by someone else. You probably already have some virtualized workloads that also sit in a traditional hosting environment, and we highly recommend that you tap into the public cloud as well. Having these environments allows you to then optimize what workloads you're going to spend capital expense dollars on, meaning that the application will live for the full period of amortization that you're going to apply to the hardware that will be consumed inside your data center. Anything you don't want to spend CapEx dollars on and you prefer to have OpEx applied to should be outsourced. These are circumstances in which you don't want to own the hardware, you don't want to have to amortize it, you do want to be able to tune it up and down on an annual basis, but you don't really have the flexible OpEx that you get from the public cloud. And for anything that you want the high flexibility, where there is transiency or elasticity, you want to be migrating those applications or building those applications for consumption on the public cloud. So all of this can be achieved in the first stage of cloud economics. What we're going to focus on now is how you get to the second and you get to the third stages of cloud economics. A key thing to understand is there is a difference between a public cloud and there are 2 types of private clouds that you can consider. There's a hosted private cloud and there's an internal private cloud. Internal is the one that's running inside of your own data center, consuming your own resources. And your IT operations team has to run it. This is a total cost consumption on your part, and you do have some degree of elasticity and flexibility here, but it is exposed to the business units inside of your company, not something that you can flex as an entire company up and down. A hosted private cloud is something that is outsourced, so it again is an OpEx play, not a CapEx play. And in this circumstance, you still have a dedicated set of resources specific to you, but it's managed in most cases by the provider, not by you. So you don't have to worry about whether your IT staff is actually ready and prepared to operate this cloud. You can trust the hosted service provider has that capability. But again, this is not going to elastically scale like a public cloud. Your whole company is going to consume it. A public cloud is what we've been talking about before. So you're going to be sharing the environment with other companies. You can still put your workloads here, but when you turn a workload off, you don't pay for that resource. In the other two circumstances, when you turn off the resource, you're still paying for it because there's a total capacity that you've committed to over the long term. So when you're thinking about private cloud, this is a really important aspect to look at. And this is the transition point between stage 1 and stage 2. Now in stage 2, the focus shifts from putting applications that can take advantage of the cloud onto those applications that are already there. How do we now get them to scale down? How do we get them to always be coming back to zero or always be coming back to as small a footprint as possible? And this is a big focus area for companies who already have 1 to 2 years of experience in the cloud. In fact, most companies have to have 2 years or more before they really start transitioning into this stage. Stage 3 is where you can now say, I understand enough about the cloud and about how it scales up, how it scales back, how I have to break applications into different components, that I can now say, I'm going to start building applications in a different way. I'm going to start building them so that they automatically take advantage of these capabilities, and I might even build applications I couldn't have built before because I just didn't have this economic model underneath them. You can then also start looking at applications that currently run in your data center and say, I can start re-architecting these applications now because I can build them differently, I can reconstruct them, I can break them apart so that they can take advantage of the cloud in a much more dramatic fashion. And when you start moving through these stages, you start getting greater and greater financial advantage from the cloud. So you definitely want to be working your organization as hard as you can through this understanding so that you can get there. Which leads me into my final recommendations before we break into the panel. Key thing is understand the profitability profile of any application that you put into the cloud. If it's revenue generating, how does it generate that revenue? And what actions are being taken by the application to generate that revenue? And are those actions incurring costs that are commensurate with the profit that we want to generate? If they're activating a whole bunch of other things and you're incurring a bunch of costs that are not related to the service that revenue comes from, there's probably something wrong in that design, and it should be looked at from an architectural perspective. Next thing is analyze the performance profile of the applications you have out there, as well as applications that are running inside of your own data center. So you can figure out which applications make sense to put in the cloud, which ones don't, and those that are there, how you start getting them to start to scale down. These are important things to pay attention to, and it involves a methodology Forrester we call strategic right sourcing, which allows you to do this kind of analysis per application. The last recommendation is to start to bake cloud economics into your development team's thinking so that they can really understand when we're thinking about building an application, can we build it in the cloud first so we take advantage of cloud economics? If we can't do that, can we architect front ends to existing applications? Can we re-architect applications to take advantage of this? And can we build applications that cover the hybrid that I showed before, where we know there's parts that won't scale, and so we build them so that they have a small footprint in the fixed area, but we make sure as much that does scale will. Those are the key things you're going to want to keep in mind as you're paying attention to the economic picture of how your company takes advantage of cloud. So with that, I'm going to pass the ball back over to our host to lead us into the panel.
Thank you very much, James. That was fantastic content. Now we're going to move into the Q&A panel discussion. As a reminder, if you have a question you'd like to have answered by the panel, please ask it via the questions area in your GoToWebinar control panel. At this point, I'd like to introduce other panel members for the Q&A session. As I'm introducing the panel members, you will see 2 short poll questions pop up, and these are for those of you in the audience who are seeking CPE credits for today's webinar. Each poll will be left up for a short amount of time, so please respond as soon as you have seen the poll questions. You'll need to answer the poll questions in order to claim your CPE credits for the webinar this morning. I am very pleased to introduce such a great panel of experts. So again, please take advantage of this great opportunity to tap into their vast knowledge during the Q&A session. And we're going to apologize on the time side. I think we're going to run the Q&A just a little bit longer than the top of the hour so we can make sure that we take advantage of this tremendous opportunity. On our panel, in addition to James Staten from Forrester Research, we have Rob Bottcher, Director, Solutions and Architecture, Global Service Provider Cloud Practice, Cisco System. He leads a team of architects who work with service providers to design managed cloud offerings. He has over 20 years of networking and telecommunications experience. During his career, he's held various engineering and operational roles at networking equipment manufacturers. He joined Cisco in 1997 and has worked in several technical and leadership roles supporting Cisco's service provider enterprise, public sector, and commercial markets. Mr. Bottcher received a Bachelor of Engineering degree from Stevens Institute of Technology in New Jersey, and he holds an MBA in Finance from New York University Stern School of Business. Our next panel member is Dan Hushin, Senior Director and Distinguished Engineer from EMC. As I mentioned, he's Senior Director and Distinguished Engineer in EMC's Office of the CTO. Dan runs the Advanced Systems Engineering Group with a key focus on cloud service providers and Internet scale/big data information analytics. As CTO for EMC's Service Provider Program, he's rationalizing the strategic and technical portfolio in order to architecturally align the IP product strategies for emerging requirements. He's also responsible for broader information systems architectures and the big data platforms that are exploited by clouds and enterprises to move the manageability, scalability, serviceability, and sustainability improved insights derived from big data. Our final panelist is going to be David Ayers, Senior Product Manager, Cloud Services, SunGard Availability Services. He leads SunGard's Enterprise Cloud Vision and Strategy for North America and has over 13 years' experience working in hosting and cloud product management. Prior to joining SunGard, he focused on launching cloud storage for Verizon Business. During his Verizon tenure, he was also product manager for managed hosting solutions. He has a comprehensive hosting background, including a technical training position at Symantec, as well as sales engineering experience at both Verizon Business and Sun Microsystems. David holds a Bachelor of Science in Information Technology from Christopher Newport University. As you can see, we have a very prestigious panel here this morning. So I'll go ahead and get started with our first question for the panel. Our first question I'd like to direct to Rob Bottcher. We have a question regarding how firms can use cloud technology to help mitigate operational risk. Would you like to comment on that, Rob?
Yeah, that's great, and a great question. It really depends on what type of clouds we're talking about, and as you saw from the question before, we really have to determine, are we talking about public clouds or private clouds, because the risk factors actually change quite a bit if you're looking at public or private clouds. If we talk about a public cloud infrastructure, which is what I've been helping our service provider customers to build and develop over the last couple of years, you really look at a couple of different aspects of risk. Really, the first one is around financial risk. The second's around security risk and risks around security, data security. And a third risk that we look at is around disaster recovery and physical risk. When you look at each one of these, you can look at how clouds help out and mitigate some of this risk. From a financial perspective, as we've spoken about, or as James has spoken about in his presentation, there are different aspects of how you can offload different services and ramp up and ramp down various services over time to build some of that financial modeling and financial risk out of your network. Allow for things like elasticity to build workloads, so you don't have to invest in a very large infrastructure when you're initially turning up a service. And then again, scaling down, I think it's just as important as scaling up. From a security risk, you can certainly move applications out into either a public or a private environment to mitigate some of your security issues. Of course, when you build a cloud environment and it's in a public environment, you do need to make sure you have the proper firewalling mechanisms and multi-tenancy built into the cloud service that you are using. When you have it on a private cloud, it enables you to put some of your applications out in an environment where maybe they're physically disparate from other environments or other applications, so you can actually build some security mechanisms into it as well. And in a third area around disaster recovery, it allows you to move certain applications possibly off-site into other environments, or build that geographic dispersity. So if you do have a disaster situation in one data center, it's easy to move the applications from place to place. especially if you build on a cloud infrastructure, because it allows some of that portability and elasticity around it.
Okay, great. Thank you very much. I think that one of the initial myths about cloud computing was it was actually added more risk to your organization, but it seems like from your answer there that if we look at that through the correct lens, that it actually helps mitigate that technology risk across the enterprise.
Absolutely. Absolutely.
Next, I'd like to direct our question to Dan Hushin. Could you comment on how you've seen the cloud's flexibility help CFOs and finance executives with month-end closings and financial reporting, how they can leverage that?
Absolutely. Thanks very much for the question. So, my background is really looking at some new dynamics of cloud computing, which is really to look at big data crunching, and certainly some of the prior panelists' discussion of using clouds for these big data workloads is right up the alley. What we've seen in SaaS and a number of other analytic products is that many of these products are moving to substantial amount of cloud readiness. And what I believe the advantage that this gives is twofold. So one is the ability to run analytics across infrastructure, which would otherwise be very, very expensive to acquire, that could allow you to do things like game theory and portfolio analysis in a way that you could quickly generate a number of different scenarios and realize which of those scenarios fundamentally represents the most effective either use of cash or positioning of assets. So if you needed to do a write down or sell or something at the end of quarter or just prior to end of quarter, you could actually run a lot of those analytics using cloud resources that substantially reduce costs and nearly $0 procurement costs. So I think there's a huge advantage there. I think the second piece comes down to the other aspect of the computing, which is the fact that most of the clouds actually give you a very, very strong amount of information about your metered usage and your usage patterns, which helps you both with prospective planning, but also a substantial amount of insight with respect to where the cost should be appropriately allocated within the business. And I think that both the ability to use it in a planning scenario for ad hoc analytics, but also to give you a much more visible cost model for the operation of your business are hugely advantageous.
Okay, thank you very much, Dan. That was a fantastic answer. Now I'd like to direct a question to David Ayers from SunGuard Availability Services. How have you seen cloud technologies bring strategic benefits to some of the clients that you work with in the sense of transforming their business models to leverage the cloud to gain a competitive advantage?
Well, that's a very good question. I mean, really, I've seen these technologies benefit customers by really allowing them to focus specifically on their business and the needs of their business rather than, I think, focusing on what we all hate to consider the more mundane aspects of data center operations, of software maintenance, of applying security patches, of handling firmware updates and software updates and all of that. By leveraging the cloud, customers are really able to realize what I like to characterize as realizing the business outcomes that they're trying to achieve on this. So therefore, we're able to accelerate, I think, customers' business initiatives. So let's say we have a customer that is already they already have an application that's running, could be on legacy environment, hosted, in-house, whatever, and they have a brand new initiative. The cloud is a great vehicle for those customers to use to say, I need to spin something up, quickly. I want to do it efficiently. I don't want to have to worry about how I actually, achieve this outcome that I'm looking to achieve there. But really, what is it I want to do? And let's just have the cloud enable me to be able to get to that outcome very quickly. So it's great for hitting these new initiatives that people that are trying to launch and spin up there with as little friction as possible. So I think that's one good characteristic that I see.
Yeah, if I can add, I mean, from my perspective, we see the venture capitalists really being industry leaders and understanding how to manage cash flow position of startup companies. And as I look across where those investments are happening, not barely $1 of funding from a venture will go into a data center that one of these startups will own, unless it's really a core competency of that startup. They're really looking very aggressively in your business plan and saying, hey, are you doing this in the cloud? Because they're very, very concerned about things like utilization and wasted cash on kind of building for scale before the scale exists. So, just looking at the marketplace and where these public clouds are being exploited by these startups should say that if you're an enterprise and you're driving new applications and new strategic initiatives, you should probably be operating those more like a startup in which you're able to incur the costs in line with the acquisition of revenue.
Okay, that's great. Just want to make a little comment, about what David was talking about. It's become more and more common, for the CFO to own IT. So instead of the CFO and the finance department doing some of the IT functions, they focused on what they can do best, which is add strategic value to the company and focus on that for the company. Have a question for James. Someone's wanting to get some clarification on the difference between what you termed an internal cloud and your own server at your company.
Well, so the key thing is an internal cloud has to meet the same definition as a public cloud. So while you have traditional environments inside your data center today, which are static and are not metered and are not necessarily automated in how they're deployed, managed, and maintained, you probably still will have those types of environments long-term for traditional workloads that aren't cloud-ready or cloud-appropriate. So an internal cloud is a specific pool of resources that are set up like a public cloud. And when I say that, I don't mean that they're publicly exposed. They're still internal resources, but you slice them up between the different business units inside of your company. So you'll have engineering as one of the tenants, much as your company would be the tenant of a public cloud. And you want that service to be automated. You want it to have self-service to those developers and those business users. And you want it very much to be metered so that you can use the cloud economics to your advantage to encourage them to only put applications there that can activate the cloud economics so that you have the cloud stay small and you're constantly reusing the pool of resources rather than growing and growing and growing that resource pool, which is exactly what happens in our current workloads today that are static and are not metered to take advantage of this. Anyone want? Anyone?
Okay, is there someone else that'd like to comment on how the cloud can leverage those synergies? Okay, I will go ahead and save that question, and we'll answer that question up on Proformative. James, do you want to comment on that?
Sorry, guys, I'm having technical difficulties and didn't hear the question.
The question was, how can my company leverage cloud in coordinating governance, compliance, and risk management across the enterprise when they're currently sort of run in silos?
Oh, yeah. Well, the challenge is if you're running in silos today, you're never going to really achieve significant efficiencies if you continue down that path. But we know that in some circumstances that is the case. What you then want to do is look at the particular silos that have the highest amount of consumption over time. And if their consumption looks very much like it might be coming and growing because of elasticity, they're the ones you want to focus on. You could approach them with an internal cloud. You could approach them with the use of public cloud as a supplement to the resources they're currently consuming. So just particularly focusing on the departments in which the most cost is being incurred is a good idea to see how you can leverage cloud economics in your company.
Okay, great. Thank you very much, James. I'd like to direct my next question to David Ayers. And this comes up quite a bit when we have seminars about cloud computing. How can I ensure that I'm complying with privacy laws for all the countries in which I have customers? Basically, how do I prove where the data actually resides for companies that have different privacy laws?
And that's a really, really good question. And I think it really comes down to, with the cloud, I think I think the service provider can only do so much. So you have a service in a particular geographic region around the world, based on specific concerns. So, for example, we're going to be releasing our product in different countries to take care of any concerns that customers may have in that region about data crossing borders. Now, some customers don't necessarily have that concern. So you may have a customer who is not regulated, and therefore they're free to put data in different regions. So if you look at some of the services that are out there now, especially in cloud storage products, customers have the ability to put data in multiple locations around the world. The service provider definitely, for the most part, doesn't have the notion of the data crossing international boundaries. So in many ways, what I think you're seeing companies do is they're stating up front that, look, we're providing a service, we are providing a vehicle for you to consume the service. However, it's up to the customer to make sure that they themselves are complying with any local or regional regulations in terms of how that data is treated. Now, with that said, one of the nice things with for example with SunGuard is that we've built our platform to really help customers be able to achieve any compliancy concerns that they have. So, for example, if customers have anything that deals with some of the ISO standards like ISO 20000, Safe Harbor, HIPAA, we can actually enable customers to be compliant in those specific areas. But again, a lot of this does really reside on the customer to make sure that they themselves, if the service they're consuming and that the data that they are putting out into the cloud is appropriate for that, either for that particular use case or that particular workload.
Great. Thank you very much. In order to be mindful of our time, I'm going to pose a question for the panel here, and I'll direct each person to comment on this if you'd like to. I have a question. Someone's asking, what is on the horizon for cloud computing? What's next? What is the next value proposition? What should we be looking for? And I'd like to start with Rob Bodicher, please. Rob?
Yeah, I think there's actually a lot of things that are exciting about what we're going to start to deliver in cloud and cloud services over time. Right now we've seen, really we're in the infancy of the service that we're starting to deliver. What we see are additional applications that we'll start seeing move toward cloud, more software as a service applications, more offload of traditional data center applications that will become more virtualized. And virtualization is really the key here of how we take applications, move them into a virtual environment, move these workloads out into more of a ubiquitous environment. And a comment on a couple of the questions that came around before, this really helps us solve some of the questions around how we build uniformity across organization, some of the compliance questions, some of the governance questions that come up. It allows us to really move these applications out into an environment where we can have a lot of uniformity. So, I look at this as we've only begun to enter the market. We've seen a couple of, really good public cloud offerings. We're starting to see the private cloud offerings really start to ramp up as organizations really understand and take a grasp of what's possible. We're starting to drive more collaboration technologies, more collaboration type applications out there, video, presence, applications such as that. So I think the future is going to explode here very soon, both in the IaaS and in the platform as a service, as well as the infrastructure, as well as the software as a service market. So I think a very bright future.
Okay, great. Dan Hushin, would you like to comment on that? And also, if you have any comments you'd like to make on the other questions that were answered?
Sure. Great answer, Rob. I agree with collaboration. I think I'm going to push it a little bit harder. I think that we are about to come up to a very interesting position in cloud computing where the advancements in technology and networking and in other technologies that service providers are going to be able to amortize across their clouds for their customers are going to provide a massive financial advance to the customers who move to those environments. And that's bolstered by the fact that I think that many enterprises recognize today that the majority of the decisions that they make are based upon information that they arrive at inside of their enterprise, which is kind of this ability to have all of the systems inside of the IT data center and to be able to make their decisions largely autonomously based upon that information, to a new world in which I need to take Twitter and collaborative feeds and other big data strategies into account to make substantially better decisions. Backhauling Twitter and backhauling Facebook and backhauling Google Plus and the rest of the social media and other elements back into your enterprise is a non-tenable economic perspective. And so as we begin to interact much more at the edge of the network with our customers, it's going to drive us to new computing economics at the edge, which are going to have this big data flavor to them, because every decision I make is going to be made based upon a deep information analytic that I provide. We think about web recommendation engines, and we begin to think about web search, and these things are largely unpersonalized or only semi-personalized today. We're going to see that every one of those interactions goes to a highly personalized environment, and the company who can make those decisions the best is going to be the best prepared. And so I think these big data clouds are going to become magnetic. They're going to sit at the edge, and it's going to be a business imperative for the companies that are looking to differentiate to be in the right position in their cloud plan.
Okay, great. James, do you have any comments to add?
Yeah, I mean, I think most of the thoughts have been said here that are appropriate. I really encourage companies to start their cloud journey with new applications, because you really are going to have a harder time transitioning or changing or re-architecting an application to activate these economics. You're much better off to start with new applications built on new architectures that are web services based or SOA in design. Those are the ones that you're really going to get the biggest bang from initially. And just as was said earlier today, for those projects, think like a startup.
Okay, great. David, do you have any comments?
I would agree with what he just said. Again, sort of what we're talking about earlier is, in thinking like a startup, it's when you take a new initiative that a lot of our customers have, this is the perfect vehicle to try it out on. If they've never virtualized before, if they've never taken advantage of the economics that cloud can offer and the benefits that cloud can offer, taking a new initiative and putting that workload on cloud is usually the entree and the first step. And then what you'll see is, again, you'll see more applications being pushed onto the cloud. And then when ultimately you start seeing, I think when customers reach an inflection point, either they're now at a point where the hardware or the software or the operating systems that they're currently running are now, end of sale or approaching end of support, you start seeing them become much more comfortable in putting additional workloads that make sense out into the cloud. One of the other things we talked about earlier was the hybrid solution. Again, I couldn't agree more with that logic, because you're always going to find certain workloads that just don't lend itself to the economics or to the pattern of running on the cloud, and that's a place that we see customers really gravitating to, those providers that can actually offer the best of both worlds. Some economies that work on the cloud, and then some that still need a dedicated hosting solution.
Oh, thank you very much. What I'd like to do at this point is close the Q&A session. As I mentioned before, if we didn't get to all of your questions, what we'll do is get those questions posted and answered on the Proformative website. And the other thing that we'll do is we'll be sending out a survey, as we always want to improve the ROI we offer to our attendees, and that will afford you the opportunity to let us know if you'd like to be directly connected with any of our speakers here today in order to get your questions answered. So I'd like to give out, again, thanks to James Staten, Forrester Research, Rob Bottich, Cisco Systems, Dan Hushon, EMC, and David Ayers for SunGuard Availability Services for their time and insight today. Fantastic panel. and we appreciate the time that you've given us here to share your knowledge with us. And then lastly, what I'd like to do is I'd like to thank the audience for your time and for your support of Proformative. I look forward to seeing all of you out online on Proformative.com, asking questions, getting your answers, and getting your work done. So with that, I'd like to close the webinar at this time. Thank you very much, everyone. And again, we appreciate your support of Proformative. Have a great day.